Thomas Jefferson National Accelerator Facility is a laboratory for basic nuclear physics research operated by the U.S. Department of Energy. At Jefferson Lab, scientists can advance our understanding of matter itself by probing quarks and gluons in the atom's nucleus with beams of electrons from the superconducting accelerator. Jefferson Lab has an educational mission as well. The Jefferson Lab Science Series features scientists and engineers who are gifted in making their work not only informative but fun. The Science Series is held once a month in the Jefferson Lab Auditorium. The presentation is live, spontaneous, and unrehearsed.
Good evening. I'd like to welcome everyone to Jefferson Lab and this evening's presentation, Chemistry, It's More Than Just Puffs and Bangs. My name is Jan Tyler, and this evening I have the honor of introducing our speaker, Dr. Joe Schwarcz. Joe Schwarcz is the director of McGill University's Office for Chemistry and Society in Montreal, Canada. This office is dedicated to the explanation of science to the public, teachers, and students in an accurate, balanced, and responsible fashion. Dr. Schwarcz teaches in the chemistry department and lectures on nutrition and alternative medicine in McGill's Medical School. He is well known for his informative and entertaining public lectures on topics ranging from the chemistry of love to the science of aging. Dr. Schwarcz appears regularly on the Canadian Discovery Channel, TV Ontario, and Global Television, and has had a weekly radio phone-in show for over 23 years. Please join me in welcoming Dr. Joe Schwarcz.
Thank you very much. You know, I often get asked how I got into this business of communicating science to the public. And I'd like to start out by telling a story, which is a true story. And I'd like to tell this for several reasons. One is that I think the story is interesting, and the other is that it shows you that you never know the twists and turns that life is going to take and how you end up where you eventually end up. This goes back all the way to when I was 10 years old, which let me tell you was a few years ago. And I was invited to a birthday party. And I remember this very well. It was in the apartment of my friend, and we sat in the living room. And there were about a dozen of us. And there was to be entertainment. And the entertainment was a magician. Well, he was a teenager, but at that time to us he looked like an accomplished pro. In retrospect, though, virtually everything that he did is eminently forgettable. But one trick has stayed with me forever, and that was the life-changing illusion. So I'd like to reproduce that for you here as I provide the explanation. He stood in the center of this little circle that we had formed. Okay, we're back live? All right, a little rewind. So there we were sitting on the living room floor, about a dozen of us. The magician comes and stands in the center, and he showed us 3 ropes. And they were tied together with a knot at the top and at the bottom. And he told us that because, of course, there were 3 ropes, there were 3 ends at the top and 3 at the bottom. And he was going to perform a miracle, he said. He was going to convert those 6 ends into 2. Well, frankly, we didn't know what on earth he was talking about. But he undid the knot at the top, and he tied together the blue rope and the white rope, just like I'm doing here. Then he turned the whole thing around, he undid the other knot, and he tied together the red rope and the white rope. And then he triumphantly showed us that he had converted the 6 ends into 2. Well, he waited for the applause, which never came, because even at that young and tender age, most of us could figure out that maybe with 2-3 years of training, we could tie 3 ropes into 1. But then he did something that I have never forgotten. He took those 3 ropes tied together with the 2 knots, and he rolled them up in his hand, just as I'm doing here. And he said, you know, guys, I never go anywhere without my magic chemical. He reached into his pocket to get his magic chemical, which he sprinkled on those ropes. And when he unraveled those ropes, believe it or not, the knots were gone, and there really were only 2 ends. And, well, there was sort of this thunderous applause, which really was not deserved. Because this is, of course, such a simple little trick. I won't even bother you with the explanation of how it's done. But you know why it has stuck in my mind? Because he used the term magic chemical. He didn't say hocus pocus. He didn't say alakazam. He didn't say abracadabra. And I remember wondering at that time why on earth he had used this expression. And this party was on a Saturday afternoon. On the Monday morning, I remember going to school and going to the library and taking out a book on chemistry and magic because I wanted to know what this was all about. And I've been thinking a magician does, of course, is done by perfectly explicable scientific means. There is no such thing as real magic. So I've always tried to make the links between those two, both for the purpose of entertainment and for education. Now, I know that chemistry doesn't have the best possible image. And you guys come to a chemistry show, and the first thing you expect is an explosion. That's sort of the image that we are saddled with, sort of the mad scientist. Well, we're not mad, angry sometimes, but we can do some pretty interesting things, which I would like to share with you here today. Unfortunately, kids get off to a poor start when they get interested, if they get interested in chemistry, because right away they link it with explosions and pops and bangs. But you know, there's so much more to it. Now, to be honest, some of these puffs and bangs can be pretty interesting. And I got interested in that when I was in graduate school because I wondered how they got Barbara Eden, who played in the old I Dream of Jeannie TV show, to come out of the bottle. The show started with her master picking up a bottle, and all of a sudden, in a puff, it looked to me like steam, she emerged. And it wasn't until graduate school that I figured out how this was done. It was a puff, but it had real meaning to it. Let me show you. It took some time to delve into this chemistry. It's okay, this one I can handle. You want to see a genie come out of that glass? Maybe we'll have more success than with the mic. Now, she needs to warm up a little bit, which is exactly what she's doing now. But here she comes. Watch this. Come on out of there. Oh. Now, you'll notice that this is an extremely exothermic reaction. It produces a great deal of heat. Take a look at what happened to that plastic cup. Now, it looks like a magic illusion at this point, but I don't leave it at that, because the real beauty in science is taking away the magic and in providing an explanation. Here's the explanation. The liquid that I poured in there was a chemical called hydrogen peroxide, H2O2. This molecule decomposes to form water, H2O, and releases oxygen gas. The catalyst that makes this happen is manganese dioxide, a black powder which you actually find inside of batteries. When I mixed these two, we had this pretty violent reaction. And what you actually saw was steam, because the reaction produced so much heat that the water changed into steam. And of course, we had this plume. And that's the way that they did the genie illusion. I actually, 2 years ago, was lucky enough to get to meet Barbara Eden, the actress who played that 30 years ago. And I asked her if she knew how she got out of the bottle. She said she didn't even remember how she got into it. And then I showed it to her, and she had never seen this, of course, because she wasn't there when they did the special effect. And she was amused by that, and I thought it would be interesting to show people that chemistry can play a role in everyday life, even on TV. But there's far more to chemistry than just that. Sure, we can make the smokes and the puffs. But the real beauty in our science is that we can make dyes. We can make the cleaning agents. The food that we eat is all a collage of chemicals. The medications we take are essentially chemicals. Everything in the world is made up of chemicals. Chemical is not a dirty word. Chemicals are not good or bad. It all depends on how we use them. The same chemical that can be used to our benefit can also be used in a detrimental fashion. And unfortunately, some people focus on that and say that chemistry is the work of the devil because they look around and they see the toxic waste that is produced and the pollution. Well, there is some of that, admittedly. But that is sort of the cost of doing business. It is impossible to do things in life without introducing any risk. What we have to do is examine the risks versus the benefits to see whether or not the science is worth doing. Science really is like detective work. And this is something that I have always enjoyed. I've been a fan of Sherlock Holmes for a very long time. And I like to create mysteries. Of course, I also like to solve them. That's the scientist in me. So let me pose you a mystery and see whether or not we can solve it. What do I have here? How do you know it's H2O? It could be vinegar. It could be concentrated sulfuric acid. What's the scientific answer? It is a clear liquid, a clear liquid. Here, I have a styrofoam cup, such as you drink coffee out of. Now, I propose to pour my liquid, which actually happens to be water, into this styrofoam cup. I will have to put the mic down to do that, but I want you to make sure that I really do pour the liquid into the cup and that at no moment do my fingers leave my hands. Liquid, cup, water. Into the cup, right? Can you hear me now? Yes. I have a pencil here, and I'm going to take this pencil and drill it right through. Look at that, the water doesn't come out. Well, I'm sure you're thinking, of course it doesn't come out because the pencil plugs up the hole. But how do you then explain this? It still doesn't come out. Now, oh yeah, I heard it. Those of you who know a little bit of physics say, oh yeah, he turned it so fast, it's centrifugal force that keeps it in there. But you know what? I'm a chemist, and we are better than physicists. Let's see if physicists do this. Out. Now, what we have here is a mystery, correct? It looks like a magic trick because most of you don't know how it is done. Of course, the magic disappears as soon as science rears its head. How is it all done? Trick pencil. No, you're not going to buy that one, huh? It is in there. Except it is no longer a liquid. I had in the cup a powder. Now, of course, I didn't show you that I had it. That was the whole point. And I never told you that that cup was empty. I suggested that it was, but I never said so. I never lied. Right? Now, this chemical is a very interesting one. Affectionately in the trade, we know it as super slurper. It's a polyacrylate, which has a fantastic ability of absorbing water. You find it in diapers. If you ever cut apart a super absorbent diapers, that's what's in there. So I had a little bit of the powder, poured in the liquid, it absorbed the water, and, of course, created the magic. But now, the magic is gone. Science has appeared in its place. And babies all over are thankful. Now, talking about babies and kids, we are blessed as scientists with having raw material that we work with that expresses a great deal of curiosity. Children are innately curious. As soon as they are born, they start wondering. They wonder about all kinds of things. They wonder about their navel, how to get the dust out of there, how to clean it. Of course, what you do is use navel jelly, which I'm sure you're all familiar with here. Well, of course, this navel jelly is not destined for the navel. It is called navel jelly because it was actually developed by the US Navy to clean battleships. This is concentrated phosphoric acid. And let me tell you, you don't want it anywhere near your navel. So it pays to know the chemistry behind these everyday things. As children age, their curiosity increases and they like to look into things more and more. But one of the problems is that as we get older, that curiosity is replaced by common everyday life, and we don't have time to think about scientific things. It would be great if we could maintain that childish curiosity well on into life. Why? Because it is useful. You never know when scientific questions are going to arise, and you have to be ready to answer them. So I want to take you through a few of these scientific questions just to show you the important role that chemistry in particular plays in our life. Food. Everybody eats, and we love to connect food to health because, of course, we all have an innate feeling that everything that we put into our mouth somehow ends up being a part of us. So, of course, it must somehow connect to health. And indeed it does. Starting from the first thing that we eat in the morning, which is cereal. Now, you wouldn't believe some of the fascinating scientific history behind it. Let's go back for a moment to the 1800s. And this gentleman, Dr. John Harvey Kellogg, a Seventh-day Adventist who was hired to run a sanitarium in Battle Creek, Michigan. You could always recognize him because he wore white all the time, and often he had a white parrot on his shoulder. He was a medical doctor, trained as well as anyone could be trained in those days, and he was in charge of a sanitarium. It was affectionately known as the SAN. And this was where people from around the world came to be cured of diseases that they never had. Kellogg catered to the rich hypochondriacs, so he obviously had a very high success rate. But he had an interesting vision of life. He believed that meat eating was dangerous, and he promoted a vegetarian diet based on whole grains. Now, a lot of his ideas were a bit obscure, but indeed he was the first person ever to try to mesh science with nutrition. And in the SAN, in the dining room, there actually were cards that had the calorie content of foods. That was an absolute novelty for the time. He had some rather bizarre views. He believed that sexual activity should be reserved only for marriage, and it was even better if it were avoided even then. He himself never consummated his marriage. You got that? But he did have 39 adopted children, so he was a good man, although history does not record Mrs. Kellogg's view on this arrangement. But he believed that meat eating would drive people to do things that he thought they should not do. And it was by eating the proper foods that they could avoid falling into this trap. And that indeed was the philosophy that was propounded at the SAN. Eventually, the original building was replaced by a much more modern one after it burned down. And it was in here that he really put his ideas into practice, especially in the dining room. That was the dining room in the SAN. And as I said, people from around the world came to feast there. And believe it or not, it still exists. Today in Battle Creek, it's a federal building. And this room has been rebuilt to be just like it was over 100 years ago in all of its glory. It's actually fascinating when you go there, and I've been there, so I can show it to you. And here it is, what it looks like today. It cost millions of dollars to redo it, and I think they should have spared a few thousand to put in some tables other than these IKEA ones, and to try to put something of the history in there. But it is fascinating. It was in this room that one of the most important nutritional breakthroughs was made. Because one day, a patient bit into one of Kellogg's hard loaves of bread and broke a tooth. It was a whole grain bread, and decided to sue Kellogg. Well, Kellogg didn't want to have anything to do with this. He settled with her, and he decided that this would never happen again. So he went into the Sands kitchens with his brother Will, and they experimented to see how they could turn this hard loaf of cornbread into something that was much easier to chew. And out of that experiment, of course, came Kellogg's Corn Flakes, the world's first health food, which he promoted as an antidote to meat. Why? Because meat did all of those nasty things that I told you about. Now, of course, the Kellogg company today no longer speaks about that particular vestige of its history. But the cornflake really was the world's first health food. It was very quickly joined by a large variety of other cereals. And today, of course, there's dozens and dozens of cereals, but all go back to the time of John Harvey and Will Kellogg. Today, there's a lot of controversy over these cereals. Some activist organizations that are against genetic modification portray these cereals as being dangerous because, according to them, they contain genetically modified and untested products. Well, they're wrong on both counts. These cereals do not contain genetically modified corn, and genetic modification is not a bad process, and it has been thoroughly tested. So you've got to look at the real issues behind the science, not only just the headlines. In any case, I like Tony the Tiger. I think that they do a pretty good job. I think he puts a little bit of too much sugar in his Frosted Flakes, but I have no problem with his genetic modification. One of the patients at Kellogg Sanitarium was a gentleman named Charles Post. Well, Post recognized a good thing when he saw it. If the Kellogg brothers could become rich from selling cereal, so could he. So he, of course, began the Post Empire. And his first cereal was Grape Nuts Flakes. Still around today. It made him a fortune. What is really interesting about this comes from looking at the label. It is actually a good cereal. Whole wheat. It's fortified with vitamins. It's got all kinds of good nutrients. But what you will notice, conspicuous by their absence, are grapes or nuts. There were never any grapes or nuts in Grape Nuts Flakes, and there still aren't today. He just thought it sounded healthy. You can call your cereal absolutely anything that you want. So there are no grapes or nuts in Grape Nuts Flakes, but there is a cherry in a cherry blossom, which is a very interesting kind of candy. When you bite into it, liquid oozes out, and you have a cherry sitting smack in the middle of it. Of course, the question comes up, how do you do this? How do you technically have this chocolate with a thick liquid inside, and sitting in the middle is a cherry? Now, this takes some really neat chemistry. And it's pretty simple. I can teach it to you. Sucrose is the chemical term that we use for ordinary table sugar. You know that it is soluble in water. You put a spoonful of sugar into water, into coffee or tea, it dissolves immediately. Sugar can be broken down into glucose and fructose. It's what we call a disaccharide, easily broken down. Well, it turns out that glucose and fructose are even more soluble in water than is sucrose. So here's what they do. They take some sugar, add a little bit of moisture to make a paste. They mold that paste around the maraschino cherry, which is then dipped into melted chocolate. But just before dipping it into melted chocolate, they add an enzyme called invertase. You can see it on the label here. That enzyme, over a period of about 2 weeks, breaks the sugar down into glucose and fructose. There was not enough moisture to dissolve the original sugar, but now, because the glucose and the fructose which are formed are more soluble, they will dissolve in the small amount of water, and therefore it changes from a paste into a syrup. That's the magic behind it. You must never consume it prior to its time, which is about 2 weeks. That's the proper vintage for a cherry blossom. But of course, they're never sold before that period. So it's some really interesting science here. And now that I've revealed that, I'm sure there's still one other burning issue in your mind about chocolate. And that isn't how you get the cherry into the cherry blossom, but how you get the caramel into the caramel bar. You really don't have to sell your soul to the devil the way that the advertising suggests in order to do that. This really is an engineering problem. It's not a chemical problem. You have a mold. You take melted chocolate. You just pour it in until it lines the mold. You cool it down. Then you take caramel, which is just melted sugar, pour that in, cool it down, and finish it off with a layer of melted chocolate. That's the magic behind that. Of course, the real magic behind chocolate is why we love it so much. Why is it that on Valentine's Day, we give boxes of chocolates to our loved ones, thinking that it is going to increase romantic adventures? Well, there's a fascinating story about this. About 10 years ago, researchers discovered that there's a chemical in the brain called phenylethylamine found in higher concentrations in people who are in love and in lower doses in people who have been recently jilted or who are not in love. But of course, the real dramatic breakthrough was when they discovered that this chemical was also present in chocolate. Well, that of course made headlines. Chemical of love found in chocolates. Well, first of all, how did they know that this was a chemical of love, given that lovers are not likely to donate their brain for scientific research? Well, it turns out that this compound phenylethylamine in the brain is converted, metabolized is a term that we use, into another one called phenylacetic acid, which shows up in the urine, and we can test for it. So to put it very bluntly, people who are in love pee differently from people who are not. Pee. So we know that there's a relationship between levels of phenylacetic acid in the urine and phenylethylamine in the brain and being in love. Then the researchers found the same chemical in chocolate. So obviously there was a connection. However, science here is less romantic than fiction. It turns out that the phenylethylamine in chocolates goes directly to the hips without passing go in the brain. But it's a neat story, and it comes out every Valentine's Day, even though it isn't scientifically accurate. Why is it that we really love chocolate so much? Well, because it tastes good, and because cocoa butter, which is the fat in chocolate, melts at body temperature. So as soon as you put the chocolate into your mouth, it will immediately begin to melt, and it gives you this smooth, flowing sensation. Chocolates are really neat. Everyone loves them, especially this one of the most popular chocolates in the world. You know that they were born during the Second World War, when American soldiers used to have chocolates in their battle rations. But some of these soldiers had to wage war in warm climates like in Africa, and the chocolate would melt all over their hands. And when they picked up their rifles, their fingers would slide off the trigger. So the U.S. Army commissioned a study to be done to make chocolates melt in the mouth and not in the hand. And this challenge was taken up by a young chemist named Alfred Stern, who had just escaped Hitler's Nazi Germany and come to New Jersey and found a job at the Mars and Murray Company. And he already had some knowledge about candies, and he thought that by taking little bits of chocolate and coating them with candy, he'd solve this problem. And at first it seemed that he had. But then, when they shipped off these little candies to the warm climates, the candy didn't melt, but the chocolate inside expanded, because he didn't contend with the fact that chocolate had a different coefficient of expansion from the candy. So it cracked and the chocolate oozed out. He went back into the lab and discovered that by beating air into the chocolate as it was cooling down, he formed little bubbles in the chocolate. So then you could coat them with candy, because now when the chocolate melted, it melted into the little holes. It expanded into the holes. And so it is to this very day. You can check that out. You can get yourself some M&Ms. You can do an autopsy. Take a look inside. and you'll find the little bubbles that helped defeat Hitler. So after the war, everybody, of course, wanted to get these chocolates. And they were wildly popular because there were all kinds of beautiful colors. There were reds and greens and purples. But in 1976, all of a sudden, red M&Ms disappeared. There were still all of the other colors, but the red ones disappeared. What was going on here? The candy that had been invented by the army all of a sudden lost its red glow. Well, a story started to go around that the reason the red ones disappeared was because the red dye that was used was an aphrodisiac, something that induced people to fall in love, and that workers were stealing them from the assembly line. This is not true. As you probably know, it's the green ones which are aphrodisiac. No. This story came about because the Russians in the early 1970s had actually done some studies on a red dye called red dye number 2. And it turned out to be a problem. It was carcinogenic, cancer-causing. At that time, the US said, what do the Russians know about red? And they completely ignored those studies. But in 1976, a study was done in Canada which showed that it was carcinogenic there too. This time, US paid attention and removed red dye number 2 from the market, although it was never used in M&M candies. But the reason that they removed their red dye was because people had read about this and they were worried that there would be massive confusion and people would stay away. Boy, was that ever bad for business. People clamored that they wanted the red M&Ms back. Why? Little girls wanted them to paint their lips with, play lipstick. Mothers said they needed red, green, and yellow M&Ms to teach children about traffic lights. Otherwise, there would be accidents. But because there was this worry about the dye, even though it was not the right dye, for 12 years it stayed off the market. In 1988, it was reintroduced. So you can see the fascinating story behind the disappearance of the red M&Ms, which now have re-emerged. Colors are a very important part of our food, not only in M&Ms, strawberries too. You ever wondered why you very rarely see strawberry muffins? You see all kinds of other muffins, but not strawberry muffins. Let me tell you why. When you bake muffins, you use baking powder. That's basic. It's alkaline. The red pigment that we have in strawberries is a natural indicator which changes color in the presence of a base, so that strawberries actually start to look like that in the presence of baking powder. Well, not quite as intense as that, but at least look far, far less red. And that does not have much market appeal. That's the reason that you don't see strawberry muffins. But getting to a more interesting question about strawberries, have you ever wondered why it's not good to drink nail polish remover, but it's okay to eat strawberries? No? Let me tell you why this is something that we can wonder about. When we do a chemical analysis of strawberries, we find that it contains a substance called acetone. This is exactly what you find in nail polish remover. So how come that we don't drink nail polish remover, but we eat strawberries? Hopefully the answer is obvious. The answer is that, yes, the acetone is there. It is the bulk of the nail polish remover, but it certainly is not the bulk of the strawberry. There's very little acetone in strawberry. Acetone can be poisonous. However, a very important point in science is that only the dose makes the poison. It doesn't make any sense to ask a question without talking about the context. Is aspirin poisonous? Depends, doesn't it? If you have a headache and you take an aspirin tablet and you lick it, your headache will not go away. If you take 2 aspirin tablets and you swallow them, your headache will go away. If you take a whole bottle of tablets and swallow them, you will go away. So only the dose makes the poison. A very important concept. I'll give you an interesting example, because we delve into every area of life here. Agatha Christie wrote some wonderful mystery stories, and many of them revolve around poisons. in the mysterious affair at Styles, in which she introduced her champion detective, Hercule Poirot. The story is about strychnine, a poison. Some of you may have heard about it. It's used as a rat poison. It's actually produced by the nuts of a tree that grow in Hawaii. Up to about 1920, dilute solutions of strychnine would be given to sick people who had heart problems to stimulate the heart. And in the story, an elderly lady is given a strychnine tonic. One day, a doctor is called because in the morning, she wakes up and has seizures. Very characteristic of strychnine overdose, and she very quickly dies. The doctor recognizes that this is strychnine poisoning, but can't understand what on earth is going on. She had been taking this tonic for months without any problem, and all of a sudden she overdoses. Well, it turns out that the murderer, unfortunately, knew some chemistry. He had gone into a pharmacy and purchased some potassium bromide, which in those days was sold as a sleeping agent. Maybe you've heard the expression, take a bromide. It means calm down. He knew that strychnine was soluble in water, but when you added potassium bromide to the solution, it caused the strychnine to come out of solution and precipitate. So he added a little potassium bromide to the old lady's medicine, which caused the poison to precipitate to the bottom. So every day when she was taking her medicine, she was just pouring off the liquid at the top. And then finally she got to the bottom, she consumed this slurry, she thought that was the way it's supposed to be, and she died of strychnine overdose. Luckily, Agatha Christie knew enough science to describe this in proper detail, and her detective, of course, solved this particular problem. So poisons are interesting, and they're interesting not only in fiction, they're interesting in real life too. Witches, for example. Witches were the forerunners of our modern-day chemists and physicians. Now, of course, they were not real witches in the sense of flying on brooms. They were ladies who were usually denied an education and had to experiment by themselves. And they found some pretty interesting things. They discovered, for example, that the belladonna plant contained a juice in its berries that could be used for various purposes. They would sometimes rub it on their bodies, and they would have hallucinations. You'll notice that in many, many old textbooks where they talk about witches in the Middle Ages, they will not be wearing any clothes. And that's because in their ceremonies, they would rub themselves with what was called witch's ointment, which contained the belladonna extract, which produced hallucinations. So they really flew, in a sense. Of course, they never got off the ground. But that is probably where the stories of the broom got started, about hallucinations. So poisons are interesting in real life as well as in fiction. Now, talking about flying, witches didn't do it, but we do. We go into space in rockets all the time. You ever wonder how that happens? Well, there's fascinating chemistry behind this. I can't duplicate the space shuttle for you here, but I can surely show you the principle behind it. Because what we have here is a material that is highly combustible, that burns. And when it burns, it produces a great deal of hot gases, which emerge from the vehicle and by Newton's third law, push the vehicle in the opposite direction. Let me put this down for just a sec. This is my rocket here. Of course, it's playing the role of a film can, but it is a rocket. And here I have an old barbecue lighter, and its purpose is to produce a spark. I need a fuel. Alcohol happens to be a very good fuel. In fact, we can even run cars on alcohol. We put about 10% alcohol quite commonly into gasoline. I will put a few drops of alcohol in here and put this on, and with the warmth of my hand, I'm going to vaporize the alcohol. Alcohol is a liquid, but it has a pretty low boiling point. So if I just hold it for a few seconds, it will change into a gas. So this container is now filled with a combustible gas. And of course, I do have an ignition system. That ignition system is the barbecue lighter. So let's see if we can duplicate a liftoff. 5, 4, 3, 2, 1. The warmth of my hands may not have been enough. Or I may not have put in enough fuel. Or it may not have sparked. I normally, to tell you the truth, I normally use methanol for this reaction. Why would I use methanol instead of ethanol? Anyone know? Methanol has a much lower boiling point, and therefore it's much easier to convert it into a vapor. But what we have here was ethanol, so I'm making do, and I'm trying to warm it up. It has somewhat of higher boiling point, so it's a little harder to warm it up. That may be the reason that it isn't sparked that time. We'll give it one more shot. 3, 2, 1. Now that's not that impressive. But it does demonstrate actually the same principle. Of course, the shuttle does it on a much, much bigger scale. It is also the principle behind popcorn, believe it or not. This is the same kernel of corn in a time-lapse photograph. Why does it pop? Because inside of the kernel is a drop of moisture. You heat that up, it changes into steam, and it blows the whole thing inside out. The white stuff originally was on the inside of the kernel. Now you can prove that, because you can take a piece of unpopped corn with a needle, make a hole in it, and then try to pop it, and of course it will not pop, because now there's an escape for the steam. So instead of making popcorn, now you've made a rocket. And if you do it right, it will skitter about as the hot gas comes out, pushing it in the opposite direction. The holes in Swiss cheese are also formed by gases. Now, you may be confused about that. You probably think that there's some esoteric process, complicated process for making these holes, that you need Swiss cows and you need a special kind of Swiss cow to do this. Well, not really. What you need is a special fermentation process that produces carbon dioxide gas. And the reason that there are holes in Swiss cheese is because as the gas tries to get out, it forms the holes in the cheese. Very much like when you use yeast to make bread rise. It forms a gas, carbon dioxide there too, that causes the bread to rise. So fascinating science behind there too. You don't really need cows like that look as if they had been riddled with bullets. But bullets too are pretty interesting in terms of their chemistry. Let me tell you this little story, one of the most fascinating ones. For this, we're going to go back in time, and we're going to go back to about the middle 1800s, and the Swiss chemist by the name of Christian Schönbein. This is a true story. One day, he took his work home with him. His work happened to be reactions with nitric acid and sulfuric acid. Unfortunately for him, he spilled his reaction mixture on the floor. But luckily for him, his wife was not home at the time. He, being a wife-fearing man, decided that he better clean up this mess before she came home. So he grabbed the first thing that he could, which happened to be his wife's cotton apron, which was hanging on the wall, and he wiped up the mess. Cotton apron. He had a wet apron on his hand, which he decided to dry in front of the fireplace. Wet apron, fireplace. Surprise. Well, Schönbein was surprised by that. He didn't know what on earth had happened. But he knew that he had made a discovery. He didn't know quite what it was. He didn't think the world was waiting for exploding aprons. But he recognized that the world was waiting for something else, smokeless gunpowder, because he noticed that when this thing burned, it produced no smoke. Let me call your attention to that. I'll do it again. Watch as this burns. No smoke at all. where did it go? Of course, you can't destroy matter. You can only change it from one form to the other. It changed into a gas, and the gas molecules are here. They're just so far apart that you cannot see them. So anyway, he recognized the fact that it burned with no smoke at all. He, being a chemist, knew that the apron was made of cotton. So he decided there had to have been a chemical reaction between cotton and nitric and sulfuric acid. And he thought that maybe this reaction could be used to make smokeless powder. Of course, what he needed was to see if he could duplicate this reaction by using cotton. So he took some cotton and he reacted it with nitric acid and sulfuric acid and decided to see whether or not it now became flammable. And as you can see, it's an ordinary piece of cotton. Don't want to get too close. You see why? It worked. You want to see it again? So he knew he had something. Within a couple of years, he found a way to do this on a large scale and to make what we call smokeless gunpowder. Let me show that to you. Because this is the product of the reaction of cotton with nitric acid and sulfuric acid. No smoke. No smoke. Now, watch what happens if we compare it to old-fashioned gunpowder, which produced a great deal of smoke like that. So this was a very important discovery. It changed the course of history because, of course, bullets and guns have played a tremendously important role, not always a good one. But it is interesting that this discovery goes back to an observation made by Schwarcz. Most people, of course, would not have capitalized on this observation, but he did. It's as important to make a conclusion based on your observation as to make the observation in the first place. Bullets, of course, can do terrible things. But we have a chemical way to stop them as well. Because bulletproof vests, believe it or not, were also an amazing chemical discovery. They work pretty well against handguns, although there are some police departments who worry because they say that when their officers wear a bulletproof vest, it gives them a Superman image. And they take risks that they otherwise would not take, forgetting that some parts of their body are not protected by the vest. Well, the material in these bulletproof vests is one that was never in the old mystery stories. You never saw this kind of stuff in Hitchcock and these stories because it's a novel development. It is a discovery made at DuPont by Stephanie Kolek, and it was a discovery that was based on nylon. Kevlar is sort of a super nylon. But nylon itself is fascinating. It was introduced in 1940. Ladies lined up around the block at Macy's when nylon stockings went on sale for the first time. They couldn't even wait until they got home. Some would sit down on the curb and put on the stockings right there. It was a marvelous discovery, but most people have never seen how nylon is made. So I'm going to show it to you. First here, then for real. To make nylon, you use two chemicals, which do not mix, as you can see. One floats on top of the other. Doesn't much matter for our purposes what they are, but if you want to know, sebasyl chloride and hexamethylene diamine. They only encounter each other at the interface. And it is at that interface that the nylon forms by a chemical reaction between these two molecules. And there is the nylon fiber. Let me do it for you for real. And it isn't hard. I I make good use of film canisters. Here are the two liquids. Now, once again, I call your attention to the fact that these are liquids. First I pour in a little bit of one, and then of the other. And this one floats on top of the first one. Now I usually pull this out with tweezers, but being in a really high-tech establishment here, they provided me with these pliers, which undoubtedly are worth a fortune. Let me reach in there and pull out the knife. There it is. This is nylon thread. And let me tell you, from that small amount of liquid, I can pull out a lot of nylon. That's only the beginning. The faster I pull, the thinner it gets. See, and those are the kind of fibers that you would use to weave into nylon stuff. Or you can mix up the whole thing and get a gob of nylon, just like that. When this hardens, you can make it into molded objects. Scrapers to scrape ice off of windshields, for example, are commonly made of this. There are many other items made of nylon, including all of your toothbrushes. Indeed, that was one of the first toothbrushes were one of the first real breakthroughs made of nylon. Because before that time, those brushes were made from the little hairs that grew on the back of pigs, pig bristles. And this was not very good for the pigs. It was not very good for humans either. Because these bristles would not dry very well. And since they did not dry well, they would harbor bacteria. And that would cause all kinds of infections. Well, what I just did here is a classic reaction that in chemistry we know as synthesis. I made a new substance which did not exist before. Nylon is not the only thing I can make like this. I can make something else that I'm sure some of you will recognize. Once again, we start with a thick liquid, but notice it is a liquid. I'm adding a second chemical to this. Now watch, the reaction occurs as soon as I stir. Remember, we started with two liquids here. Watch what happens. Anyone recognize what this is? This is something we call slime. It was first developed for the original Ghostbusters movie. They needed something really yucky and slimy to play the role of slime in the movie. So the movie director went to a chemist and asked him if he had any idea. And this guy remembered when he was young putting a substance into his hair called dippity-doo. And he thought that that was pretty slimy. And he researched it and discovered that that material could in fact be used to make slime. This is polyvinyl alcohol that I mixed with borax. The borax basically links together the long chains of the polyvinyl alcohol. It's a fascinating reaction, very much like the rungs of a ladder. That's the role of the borax, linking together large molecules. And you can see that it kind of stretches. Children always like this. And I sometimes do this in elementary schools, although one time I did this in elementary school and a little boy comes up to me and says, "Gee, sir, can I have the slime?" And being somewhat innocent in those days, I said, "Sure, kid." And he took it back to the room, his classroom. I had been in the auditorium and his teacher wasn't there. And I hear a scream from the room. And the little boy comes running back into the auditorium with the teacher in pursuit because this inventive little boy had gone back into the classroom like this. And and the teacher didn't know what on earth, you know, we had been doing. But it is kind of slimy, isn't it? It does have an application. This material will dry, and when it dries, it will spread into a thin sheet, a film, which is water soluble. You can make a plastic bag out of it, which is water soluble. They use it in hospitals. When you have a lot of infection, and they change the sheets and pillowcases, sometimes people in the laundry room would be exposed to the microbes. But these days, they put it into a bag made of that material, tie up the bag, ship it down to the laundry room, and as soon as they get it, they put it into the washing machine without ever undoing it. And the bag dissolves, and the clothes get cleaned. So it's a very interesting application of chemistry. Believe it or not, chemistry plays a role in the world of art as well. Now that may come as a surprise to you, because very often art seems to be completely the opposite of science. In university, art students make fun of science students make fun of art students. Of course, they do it more cleverly. But that's what happens. And it's really a shame, because there is great science in art. And there's great mystery too. First of all, you have to create the art out of nothing. Well, anyone can do that. But the real beauty comes in, the chemistry comes in, with the pigments and the dyes that allow you to make it all colorful. Now, there's more to it than that. Let me tell you the story of Vincent van Gogh, arguably the most famous artist who ever lived. Way back in the 1800s, once again, his early paintings were very dark and somber, the potato eaters, as it was called. And then he moved to southern France. All of a sudden, his paintings shone with brilliance. What was going on here? Well, some people say just a better climate, but no, there are some other arguments which are more interesting. Many of his paintings had yellow halos around light bulbs, for example, and that is a characteristic side effect of a particular medication. Digitalis is a drug that is extracted from the foxglove plant. And we know that Van Gogh was given this drug for schizophrenia, which incidentally he did not have. And even if he did, it was the wrong drug, but they didn't know that in those days. We know that it was given to him because he actually painted his personal physician, Dr. Gachet, showing the foxglove in his hand. This painting sold about 8 years ago for $92 million, the most expensive painting ever sold in history. Vincent van Gogh in his life ever only sold one painting while he was alive for not very much money. If you're an artist, it pays to die. So there's no question that he was given digitalis, and that is the reason that he may have painted these yellow objects or yellow halos. But there's a bigger mystery about Van Gogh, and that is, why did he cut off his earlobe? What made him do such a crazy thing? Well, again, people have suggested that he was mentally ill, that he had schizophrenia, or he suffered from an ear problem called Meniere's disease. However, it is far more likely that his problems were due to a very popular beverage at the time called absinthe, the green fairy, as it was known. Absinthe was consumed mostly by the artistic community, and it is brewed from a tree called the wormwood tree. Actually, it's a bush called the wormwood bush. And it is an alcoholic beverage, and it has a chemical in it called thujone, which is a hallucinogen. And it is believed that this is what made him crazy. And this is why he sliced off his ear. It's a very interesting possibility. At the age of 37, he committed suicide. Again, it is believed that thujone had a role to play here. This is his very last painting. And the road, as you can see, comes to an end in the middle of this wheat field. And some art historians say that he actually, with this painting, sent a message that he was going to commit suicide, that is the road of his life that comes to an end in the middle of the field. And indeed, this is the area where he did commit suicide. He shot himself. He lingered between life and death for a few days and then died. His funeral was looked after by his doctor, Dr. Gachet. And he didn't want just an ordinary grave for Vincent van Gogh. He wanted something more decorative. So he planted a tree on the grave. Theo, Vincent's brother, died about 6 months after Vincent died in Paris. The two were extremely close in life. The reason we know so much about them is because they constantly corresponded. About 18 years later, the family decided that these two brothers who had been so close in life should be close in death as well. So they dug up the two graves to put them side by side. They had no problem with Theo. But when it came to Vincent, the tree that Dr. Gachet had planted on Vincent's grave had grown, and its roots had completely enveloped the casket. So they had to take an axe, and they had to cut away the roots of that tree to take out the coffin, which they did. And then the two were planted side by side. But the fascinating conclusion of that little story is that the tree that Dr. Gachet planted on Vincent van Gogh's grave, without his knowledge, was a wormwood tree. The same tree that was used to brew absinthe. So Vincent van Gogh, in death, as in life, was enveloped in the clutches of absinthe. Well, I want to tell you one more grave story here. And it's a very appropriate time of the year to tell you this story. This grave is in Macapella Cemetery in New York City. And it belongs to Eric Weiss, who of course was better known as Harry Houdini. Next week, on this week, the black cats will be out prowling, the witches will be flying, the vampires will be biting. But it will also be International Magic Day. That is a nuance that most people do not know. And the reason that we celebrate International Magic Day on October 31st is because that was the day that the most famous magician who ever lived, in fact, arguably the most famous entertainer who ever lived, died in 1926. It is difficult to convey to you guys how famous Houdini was way back in the late 1800s and early 1900s. He was like Elvis Presley, Michael Jackson, and Celine Dion all rolled into one. Because in those days there was no TV, there was no radio, live entertainment was the only way to go. And he was an absolutely fascinating entertainer. He could get out of chains, he could get out of handcuffs. He performed all kinds of fantastic illusions on stage, including a chemical trick. And this is one of the reasons why he's my hero, because he is the first one that I can find who performed any kind of a chemical magic trick on the stage. He knew something about ink, particularly a type of ink called iron gall ink, which was very commonly used at that time. Galls are little growths on oak trees, which form when insects plant their eggs inside of the tree. And these are high in a chemical called gallic acid. When you combine this with compounds of iron, like ferric chloride, you get a dark blue complex. That's the ink. Houdini knew this. He also knew that using a chemical called oxalic acid, you could break down this complex. And he weaved a whole magic trick around this. He knew that oxalic acid could be found in rhubarb, so he had a good source of this oxalic acid. This was a remarkable feat. Now, it would not be impressive today, but in those days, to take a colorless liquid, pour it into another glass, and make it dark, and then clear it up again, was truly a marvel, especially because he told a good story with it. This was at a time when alcohol was prohibited. So he said that he had found a way to make wine and not have to worry about any government inspectors. So he showed a clear glass, he poured it into another one, it turned into wine, and he said if ever an inspector comes around, he'll just pour it into another glass and the color disappeared. Today, we would not be all that impressed by that. But with modern chemistry, we can improve on the Houdini illusion. Let me try to do that for you. Okay, we're going to mix together 3 chemicals here, and watch. First we'll change it into gold. We have the lights for a moment for this. Change it into gold. That's not so exciting. Let's do something better. What color would you like? Blue. Whoa. If you miss that, take it out. then the blue. If you like, I can take it out through the side. Push it back in. Gold, and then the blue. But this is what I really like. You take it out through the bottom, and bounce it off the walls. Throw it against that wall, this wall, and right back here. Now, of course, you realize that there's nothing to do with my silly pulling and tugging, but that doesn't make it any less interesting. If anything, it makes it more interesting. Let me explain. The yellow color that forms is iodine. Iodine undergoes a classic reaction with starch to make a dark blue complex. So I have a reaction here that generates iodine. There's starch in there. It reacts with the starch, and we get the dark blue color. A second reaction destroys the iodine. As the iodine is destroyed, the color disappears. As more iodine forms, the color comes back. It truly is a remarkable reaction. I enjoy it every time I do it, and I bet Houdini would have enjoyed it as well. So oxalic acid in rhubarb is what he used to make it happen. Now, Houdini's end is what really makes for a neat story. In 1926, he came to Montreal, and he performed at the Princess Theatre. The day of his performance, he gave a lecture to McGill University students. And one of the students drew a picture of Houdini, and Houdini really liked the picture, and he invited him next day to come to the theater, to the dressing room, to make a more formal portrait. He did. He was sitting there drawing a picture of Houdini when there was a knock on the door, which was another McGill student. This is an absolutely true story, which was another McGill student. And he knocked on the door. He was returning a book that he had borrowed from Harry. In this book, Houdini had described that he was in excellent physical condition, as of course he had to be because he was an escape artist. And in the book, he also had described how he would be able to withstand any punch to the stomach. So this kid came in to return the book, and he said, "I read in your book, Mr. Houdini, that you can withstand a punch to your stomach. Is this true?" And he was busy answering fan mail. He wasn't really paying attention. And he grunted a yes, which he took to mean, okay, go ahead. Without any warning, he punched him in the stomach twice. Houdini was too proud to say that he had been hurt, but indeed he was hurt. The lecture that he had given that day was in the Student Union building, which is still there today. Today it is a museum. And it was there that the original painting was painted. And the invitation ensued to come to the Princess Theatre. This is the room where the lecture was given in 1926. Anyway, that night, Houdini still went on stage and performed the whole show, including his classic finale, which was the Chinese water torture escape, where he was handcuffed and locked into a box with water upside down, from which he escaped. But by that time, he was running a fever of 104 degrees. He performed the next day as well. And then they traveled to Detroit, which was their next engagement at the old Garrick Theater in Detroit. His wife, Bess, begged him to go see a doctor, but he would not because he said the show must go on. The show did go on. He performed with 104 temperature that day. The next day, they had to stop it at intermission because he was so sick. He was taken to hospital. He was diagnosed with a burst appendix. They did emergency operation, but they could not do anything because they did not have antibiotics yet in those days. But he being the ultimate showman, this was on October 28th. He being the ultimate showman, fought on between life and death to die eventually on October 31st on Halloween, which was the most appropriate day for a magician to die on. The story of his death hit around the world, hit people hard, because he was so famous. His funeral was huge. He was buried in a casket that he had used in one of his escapes, underwater escapes. People lined up to view him, of course, in New York City. His casket was taken to the cemetery on streets lined by thousands and thousands of people. His grave was also unique because it had a bust of him as he had decreed in his will. Now that was very unusual because Houdini, Eric Weiss, was Jewish. And in the Jewish religion, pictures are not put onto graves or busts. He was the only one in the world. Unfortunately, that bust was stolen about 3 months later. It was remade and put back. That was stolen again. So today, the bust is not there on the gravestone, but for one day. And that day is this Thursday, when the third replica of the bust is placed on there in commemoration of his death in 1926 and in celebration of International Magic Day. And magicians from around the world gather and stand guard to make sure that that bust is not stolen. And at midnight, they do a wand-breaking ceremony to celebrate the life and the death of the most famous magician who ever lived. So if you get a chance to go this Thursday to Macapella Cemetery in New York, you will see it like this, where you will see the bust of Houdini. Well, I hope that I've been able to satisfy your curiosity about a few things here today, because after all, that's what science is about. The satisfaction of curiosity, as voiced by Linus Pauling, perhaps the greatest chemist of the last century. And satisfying curiosity is indeed a great thing. And the more science you study, the more amazed you are at the answers that come up. And chemists are not different from anyone else, even though we are often accused of being some other species. We just have a variety of answers to these questions and can do, hopefully, some neat things. So I do want to wish you a happy Halloween, but I want to do it appropriately with some proper chemistry. What are the colors of Halloween? Orange and the black. So let's see if we can make some orange and the black. The black. Those of you who missed that, through the miracle of instant replay, in celebration of Halloween, we have the orange and the black. So I hope I've shown you a few interesting things here tonight, but I want to leave you with one final message, because we did promise you some bangs. And nobody wants to go home from a chemistry show without seeing at least one explosion. So let's do that. What I have in my little flask here is water, nothing else, just water. Here I have a chemical called calcium carbide, which reacts with water to form a gas called acetylene, which is highly combustible. So what I propose to do is put my calcium carbide into the tube here, into the flask, generate acetylene, and set fire to it. And set fire to it. You notice that I did not wait very long, right? I lit it right away. I didn't let enough pressure build up. That's why it only hit the ceiling. You want to see it go through that ceiling. So, well, load it up. This time we're going to allow a little time to pass. Just a few seconds. Okay, so that we build up a lot of pressure. Ready? You know, in science, you got to learn to expect the unexpected. This time, we don't have an explosion. Instead, what we have is a lamp. Because the first explosion used up all of the oxygen inside of the flask. So now the only place where it can light up is where it comes into contact with oxygen of the air. So we have a lamp, but we have something else. We have a point, a final point. And that point is that the same chemical that can be used to make an explosive can also be used to light our way through the darkness. That decision is ours. And that is the reason that it is so important to study science, so that you can make those decisions based upon real evidence and use the science for the benefit of mankind instead of the detriment. We started with a rope trick. And I hope that throughout this evening, I've been able to provide you with some mysteries, but also to unravel some of those mysteries for you. And perhaps I've been able to stimulate you into some areas of science that up to now you didn't even consider. Thank you very much. And